Hi, today we are tackling a direct and important question from the CBSE 2025 main paper. Here I typed sample paper, actually original paper, okay? I mean examination paper. Paper code 5541, question number 19. This question tests your understanding of the Lensmaker's formula, a fundamental concept in ray optics. It is a classic problem that is quick to solve if you know your sign convention, okay? But can be a trap if you don't. Today we are tackling that question now. So when we do this question, what you want to think is, you want to recall your Lensmaker's formula. Also you want to recall the sign convention. You remember sign convention, that quadrant draw, and the left side, right side distances, positive, negative, that concept, and up, down. So everything we will include in this question, okay? So I will discuss the theory related to the numerical. The question is, an equiconvex lens is made of glass of refractive index 1.55. If the focal length of the lens is 15 cm, calculate the radius of curvature of its surfaces. Simple question, straightforward question. But if you know the lens sign convention, you can. Otherwise, you will be trapped. Okay, we will see the concepts. See, first we will recall the Lensmaker's formula. I hope you studied the derivation. It is very important, okay? 1 by f is equal to n minus 1 into 1 by r1 minus 1 by r2. I assume that you know the letter, what is representing. F stands for focal length, n stands for refractive index, r1 and r2 representing the two radius of curvature on both sides. Okay, so you want to memorize this if you are not done yet. Then next, how to understand the sign convention. The simple matter is, consider all the distance toward the left side negative, distance towards the right side positive. That is the easiest way to understand. Distance above the principal axis, if you do the sign convention, that drawing above the principal axis, that is positive values, below it negative values. So here when you come to the radius of curvature, your R1 will be plus R, EQ because of EQ, R1, R2 will be equal to R. This is a special case because it is an equiconvex lens. So for an equiconvex lens, R1 is equal to R, R2 is equal to R, because both sides same type of curvature. But R1 will be equal to plus R and R2 will be equal to the minus distance, that is minus R. Then how will be our Lensmaker's formula if you substitute that one in the equation? I will show you in the writing, don't worry. So 1 by f is equal to n minus 1 into, after working it will be like a 2 by r will form. I will show in the working. Just wait. Okay, we can start now. First, always we write what are the things given, right? Here I remember how many data, 2 data is given. First data is focal length is given, f is equal to 15 centimeter. So the second thing is the refractive index also given. Refractive index n is equal to 1.55. I said now before, it is straightforward application, so no tension. So we start the solution now. So for calculation, we will get 2 marks. Calculation of radius of curvature, you will get 2 marks. Okay. We can start from the equation what you know. That is the Lensmaker's formula. I am going to write now. 1 by f is equal to n minus 1 into, inside bracket, 1 by r1 minus 1 by r2. And from the previous slide you saw that here r1 will be equal to, it is a special case, right, equiconvex. R1 is equal to plus R and R2 is equal to minus R. And n also given, f also given. So we substitute 1 by 15 is equal to 1.55 minus 1, that is n minus 1, inside bracket 1 by r, instead of r1 it is r substituted, minus 1 by minus r, that will become plus in the middle, so it will become like 1 by r plus 1 by r, denominator same, right? So we will do the normal LCM work, simple work. So subtraction of 1.55 minus 1 is 0.55, and the numerator will be added, that is 2 by r will come. This equation I said in the previous slide. Now normal mathematics, 1 by 15 is equal to 0.55 multiplied by 2. The answer will be 110, 2 into 55, 2 decimal points, so 1.10 divided by r. Just to do a cross multiplication, change the position of denominator and numerator to make it r is the subject of the formula. So r is equal to 1.11 into 15 is equal to, you will get 16.5. So 1 times 15 is 15 and 0.1 times 15 is 1.5. So 16.5 centimeter. Okay, I will show you the mark distribution in this answer, how they distributed the 2 mark. It's easy actually. The final answer carries half mark. Okay. And in the previous step, there is another 1.5 mark for substituting the values and coming to the conclusion of 2 by r step. And for checking, for writing r1 value and r2 value as plus r and minus r, you will get half mark. Okay, now total 1.5 mark ready, right? And for writing the Lensmaker's formula, half mark. How is this question? Easy, right? Like this, if you practice numerical, easily you can do it. Thank you for watching. Have a nice day.